Hello. Hi everyone. I'll be giving my talk in English so that our colleagues that don't speak Romanian can follow as well. So my name is Mihai Barbulescu. I work for the video systems and connectivity group here at Bosch, and together with Tim Lagerberg and Albert Laszlo, I co-authored this article entitled "How Autonomous Vehicles Sense, Think, and Act." So what do we mean when we say cars can sense, think, or act? These are just sort of euphemisms for the process of gathering data when we talk about sensing, the process of processing data and interpreting data when we say cars can think, and using the data to navigate the environment when we say that they act. So let's look at these three steps, which altogether constitute this sort of loop that cars always have to go through individually. Sensing. So first of all, the car needs to have a good idea of what's around it. This is why self-driving cars need a 360-degree view of its surroundings. This is accomplished using a variety of sensors. So typically, these would be video cameras, radars, and ultrasound, and this is what we've got here at Bosch as well. As well as these sensors, we also have state-of-the-art satellite navigation, which together with high-definition maps, we use for localization, so that cars always know where exactly they are. The exterior of the vehicle is not the only thing that's being monitored, though. The interior is also monitored, so that the vehicle always knows whether the driver is capable of resuming control if this is needed. All of this data that the vehicle gets from the sensors then has to be processed and is used in what we can call the thinking stage. In this stage, the processed data is used to learn behavior patterns. What we mean by this is that the vehicle can learn how different vehicles look like, how people look like, how to detect other features of traffic, and then it can use them to calculate a driving trajectory or a driving strategy so that it can safely navigate its environment. All of this, obviously, is safeguarded so that the driving process can be accomplished safely. All of the data that we've gathered and processed is then used in the acting layer, which is highly dependent on the road conditions. So the vehicle needs to know how to act regardless of weather, so it needs to know whether the road surface is wet or dry, or whether it's icy. It uses this information to implement the driving route that was created in the thinking stage, and it needs to do this safely and react to dangers if they appear. Now, how do you actually go through the sense, think, and act process, this process that you have to repeat continuously while any sort of autonomy is engaged? Well, you use a variety of tools. So we'll begin with video systems. This is where we get images of the surrounding environment, and we use them to obtain all sorts of different features or different information. You can see some of this on the screens over there. And these are things like the reconstruction of the exterior environment. So the car needs to know how far everything is. It calculates, or rather it estimates, the distances to nearby objects. Things like the flow of objects is also very important. So the car needs to know whether other vehicles are moving or static, whether pedestrians are moving. It also calculates the it identifies the road lanes and road markings, and it uses deep learning technology to segment the image into various categories, and it identifies objects within the image. Radar systems are equally as important, and they use instead of sort of visual radiation, they use other parts of the electromagnetic spectrum to identify the distances and objects and movement of objects around the vehicle. And it can do this up to a very large distance, say up to 100 meters. It can identify objects, whether they're moving or not, and it can help with a variety of functions, including automatic braking, if it detects any sort of dangers. Ultrasonic systems also play a very important role. They work in a similar fashion to radar, but they're much closer range, so they have a range of about 5 meters, let's say. And they're great for sort of fine maneuvering. They're used in automatic parking, and you can see on the side a diagram of kind of hands-off approach. The car just identifies the parking spot, and it parks itself. Finally, the previous three that we talked about, the video, radar, and ultrasonic, those were mostly sensing and thinking. In the acting stage, essential is the electric power steering system. So in traditional vehicles, you'd only have a sort of mechanical steering system. In autonomous vehicles or in modern day vehicles in general, you have all sorts of like electronic systems that provide the driver with help to steer the car more easily and to navigate the road when the automatic driving systems are engaged. You also see in that side of the room a simulator that some of our colleagues set up, and it shows how the power steering system works. And you can go sort of play that with that in the break after the talks. It's worth mentioning that all of these are things that we work here at Bosch in Cluj. And with that, I'm going to say thank you very much for listening, and thank you for being here.